Have you ever wondered about the plethora of instruments on our favorite Comet Explorer? Well, look no further because that's the topic of this week's episode. Rosetta mission has 21 instruments, including cameras, spectrometers, and some other cool things that we'll get to a little bit later. Now, we're not going to go into all of them in depth, so make sure to check the links below for anything you're curious about that we failed to get to. So to start off, we're going to go with the cameras. The most interesting ones include ROLIS, which was the Ascent and Lander camera. It's a CCD camera with a resolution of 1024 by 1024 pixels, and that was used on Philae, so it could figure out what was going on when it was landing. Now, there's another cool one of their cameras called SIVA, which is also on board Philae, and then my personal favorite of the entire mission was OSIRIS, the optical, spectroscopic, and infrared remote imaging system camera. It was constructed in Germany. It has two lenses, 700 and 144 millimeters respectively, and both of those are on a high-resolution CCD chip, just like ROLIS. Moving on to the spectrometers, there's COSIMA and ROSINA, though we're not going to get to those in this episode, unfortunately. Let's lead off with APXS, and I bring this up because it's an upgraded version of the same X-ray spectrometer that was used on the Pathfinder mission to Mars. Going into another spectrometer, we have VIRTIS, the Visible and Infrared Thermal Imaging Spectrometer. VIRTIS explored the interior of 67P in the infrared spectrum, as well as identified the spectra of molecules outgassing from the comet. Next up, we have ALICE, which is an ultraviolet imaging spectrograph. This ultraviolet spectrograph checks out the quantity and amounts and kinds of noble gases in the nucleus of the comet, which leads us to COSAC, the Cometary Sampling and Composition Instrument, which is a combined gas chromatograph and time-of-flight mass spectrometer, and that performs analysis on soil samples and determines the content of volatile compounds inside of those samples. Moving on to cool things, we have SD2, the Sampling, Drilling, and Distribution System, which was designed to gather regolith samples from the comet and then hand them off to the Ptolemy, COSAC, and SIVA instruments for analysis. It was designed to drill to a depth of 230 millimeters, that's about 9-ish inches, pop out a probe, and then bake a bunch of samples for the spectrometers. Unfortunately, this instrument never got its chance to shine, as Philae bounced across the comet rather than stuck its landing. Fortunately, we were able to make up for this loss of science by using some of the other instruments on board to sniff the compounds as Philae bounced across the surface. Moving on, we have Giada, the Grain Impact Analyzer and Dust Accumulator. Giada also sniffed the dust, but in a little bit of a different way. It was sniffing the dust on Rosetta, and it was capturing little particles that came off of 67P during the outgassing. In addition to identifying the constituents of the comet's corona, Giada was also able to determine the speed and mass of every single one of the particles that entered into the face of the instrument. Now, my favorite of the cool things experiments on board is CONCERT. CONCERT is a great name for this experiment. It stands for the Comet Nucleus Sounding Experiment by Radio Wave Transmission, and it's neat because it has to work in concert between two devices, Philae and Rosetta. The electronics were developed in France, and both the antennas that are used on the receiving end were constructed in Germany. And this brings us to MIRO, the microwave instrument for Rosetta Orbiter. The abundance and temperature of the volatile substances like water and ammonia and carbon dioxide and such, all of those are detected by MIRO, and it uses the microwave emissions of those particles to be able to detect it. And last but not least, we come to the MIDAS, the Microimaging Dust Analysis System. This high-resolution atomic force microscope was able to investigate several different physical aspects of the dust particles when they were deposited onto a silicone plate. Thank you for listening to this episode of MicroCosmos. If you'd like to support us in what we do, make sure to head on over to patreon.com/Cosmocast. Make sure to go check out our letter to Rosetta and Philae. It's a goodbye letter. It's sad, it's not sad, it's awesome, and it was written by the entire Cosmonauts group. So make sure to go check that out. That'll be in the rest of our videos. Have a good week.